Yeah, my name's Ed. A bit of a mouthful with the title, but basically it's about data scraping pipelines and cloud costs. So I come from Bristol. This is a well-known landmark in Bristol, the Suspension Bridge in the UK, and I work for EDB. So we're the, the company that does kind of the biggest part of each Postgres release. We do tools like PG Admin, and we do the cloud native operator for deploying to Kubernetes. So I've been a cloud engineer for about 10 years, so mainly in Golang, but this data job required Python, and before that I was a Python web developer. So I've split this talk into 4 parts. The first part is about what I'm actually using the data for, to kind of paint a bit of a picture of why we're scraping the data and where it's used. And then the next part is about looking at the pipelines and how the pipelines needed a rewrite, and what were the principles that were used to do the rewrite. And then there's a bit of Python, and finally it goes on about the weird and wonderful world of cloud costs and pricing. So we start with that weird, wonderful world. We needed to get the prices for 3 of the cloud service providers, CSPs, because we produce a marketplace product which runs on any of those, plus on appliances and stuff. And so those prices on cloud, whenever you put anything on cloud, it uses stock keeping units, SKUs as they're kind of known. And if you've got 3 cloud suppliers, they each have about 200 services. Each of those services may have about 50 different types of the service. There'll be usage tiers, so it might cost more. It will cost more if you use less, be cheaper if you use more, and an average of 50 regions. I mean, one of them's got more like 80 and one's got, anyway. But if you multiply all those numbers up, you realize you've got 4.5 million cloud prices just for the 3 cloud service providers. It'll be a different price, you know, if it's in the US compared with India or whatever. And even something that seems quite simple, such as hardware disk storage, there will be the type of hardware, so that the type of disk, how fast it is natively, sort of capacity, throughput, the region it's in, and then if you've got backup, there'll be the type of backup, its retention schedule. All those things are all priced separately and create a very complex picture. So this is the product that we produce, Postgres AI. So it's basically Postgres clusters deployed across different cloud. And so those Postgres clusters will need to use a number of the SKUs for deploying Postgres. So compute nodes, volume storage, snapshot backups, network. And then you see there's vector over here. So that's PG vector. So for LLMs, you'll store those in a vector database. And so Postgres has a PG vector for creating thousands of indexes on each word. In effect, a vector database is how you store an LLM. So if you're doing work with Postgres, your data's there anyway, you can set up maybe an open source LLM using PG vector. And that's put into the lakehouse part of the system. And that also uses object storage more, a few less SKUs, but it uses SKUs everywhere. As I said, it's complicated, the pricing. This makes it look way more complicated. By my colleague wrote out a math formula for how it, and for how we actually calculate it for our microservice. So it involves some of the things multiplying up that I talked about, but also there's a form factor you may need to tweak a bit how those are costed. And then as I'll go into later, cloud pricing has numbers of different payment methods. And so once you get to private offers, you're getting a certain discount per customer. And so that discount factor has to be taken into account as well. As a diagram now to show you kind of what I'm talking about in terms of the software system. So ignoring the bit at the top, which is the actual pipeline, I'll go into more detail. The application at the bottom, just as this section is about, it's the end case of what's being used. So it's a number of microservices, and we have a price microservice that has to get populated with the price data, which changes every month. And that then goes with a discount, and we use gRPC for all the communication within the cloud. And then rather than bothering doing a JSON API separately, you can generate your JSON from your gRPC. If you annotate the gRPC appropriately, Istio has so Istio is a kind of edge server for the cloud, so it can just generate your REST API, which is what the UI guys want to use when they're generating the numbers when you're choosing different cloud options. So I'll now demonstrate how that looks in practice with the product. So this is adding a bunch of Postgres clusters. So I go and create a new database cluster rather than the lakehouse. Go for a single node, simple. This demo version just has a few regions. I use AWS, choose India South, and then specify what sort of cluster I want. And so go for Postgres 17 and go for the compute. So the speed of the compute, and then the storage for the database. And then WAL is the kind of transactional log for Postgres that you would have separate if you've got a cluster kind of deployment. And you see on the right-hand side, all these things are being selected here, and we've got a price at the bottom, and that's what we're actually using it for. This price appears. Then I can ramp up the throughput. I want it faster, I want my database faster, treble it, and it will tell me that's going to be an extra $30 a month. So it shows just as showing you basically what we're using the data for. I can then change to a different region. The price goes down a bit, but I'll skip on to part 2, which is the pipeline architecture. So the pipeline architecture involves getting the data from the cloud providers. So the first thing anyone has to do with data pipeline is look at the sources. So for cloud providers, we've got 3 of them down the bottom here. You've either got REST APIs where you just need to extract out a little bit of the data for a particular application where you need to show it dynamically. But in our case, we want bulk API to pull it all down so we can use it. So on the left-hand side, they all have bulk APIs. You can dump them down, and then they have no standard. They all use different units and different ways of pricing things. So in order to deal with that madness, there's a kube cost is a bit of a standard that IBM did, which kind of puts them all into a common data format. And then Infracost is a cloud company that gives you various features on top of that. And so we originally had a pipeline where we were using the Infracost data because we had a free sign up, and at first free sign up you were given the option to download the full dump of all the cloud providers data. So we used that. We didn't want to reinvent the wheel, to use the kind of idiomatic phrase, and simply we didn't feel it necessary to do anything different. We thought I'd eat our own dog food here. I use our own product by just running up a Postgres cloud cluster for sticking that data into. And then the transformation, yeah, it's a bit ugly, DBA sort of mentality, bash scripts and procedural SQL and stuff, which was then put into GitHub Workflow because we already had GitHub Workflow for all our CI/CD. We're paying for GitHub anyway, and then it would just push those out as dumps, artifacts to a cloud file store. So it'd be Postgres dump format because all the data was in Postgres, and therefore that was the most kind of highly detailed form that you could use without having to convert stuff. But we then realized we had to rewrite. And one of the reasons was, like most free things, it's not that reliable. So they kind of decided to not give everyone the dump anymore for the free sign up. And then they wanted quite a lot for using other stuff. And we thought, well, let's just, it's probably better that we rewrite this. We've now got a data science team, and they've settled on Airflow for all the data workflows. And it's a bit ugly that this is in Bash and SQL, especially for test. And although my team, account management team, is mainly Gophers and Rustaceans, I am a Pythonist, the only one in the team. And I thought, okay, I can do the data science stuff in Python. So we'd also never fully finished the pipeline to automate the last bit of pushing it out to the deployed system. So I redesigned it, and I moved to extract and transform it sort of at the start and then load. And so the redesign involved writing Python scrapers to directly get the data, which was a significant benefit, as it turns out, because really we didn't need these ridiculous quantity of records. We only needed a few 100,000 for our prices for our bits that we used. So if we extracted those at the beginning, that obviously saved a lot, and the Python could be used to transform. So that was much more maintainable and testable. And then I added in another feature which I found made pipelines a lot more maintainable, which is to use embedded Postgres. So most databases have forms where you can use them for in-memory, such as MySQL or Oracle. If you can't use an in-memory version, then there's embedded version. So embedded just means that within a few seconds it will create the whole set of files on your file system, run up Postgres. So you can just go 1, 2, 3. You've got your Postgres with its schema loaded. Use it, dump from it, wipe it. That is a big advantage when you're doing pipelines, because you don't want to have dependencies. I mean, you have dependencies of long-lived things between the steps in the pipeline, but it makes things more complicated. The one bit that stayed the same was the artifacts, and moved to Airflow. So this is a picture of the two pipelines, excuse me. So the top one kind of looks simpler because it really just has, we've already got the data and we're just sticking it in the database and mashing about with it. But actually, as I say, it's got a dependency of long-lived cloud Postgres, dependency of infra cost, which then causes it to fail. So the bottom one, the new one, is a lot more maintainable, as faster. We dump to the same place, but we also add in this pull. So we've only got, I mean, you could just have a single master data repository for your pipeline, but we tend to do one for staging and dev as well. But still, you've got a limited amount of those, whereas you could have masses of different deployments, tests, different developers might have temporary ones, whatever. So it's much better to pull for that thing, so you don't control what's consuming, you just look after the master. So it's the end of this section on the pipelines. So what are the data principles? Well, data currency governs architecture, and we've got no need for currency at all here. We're not live updating every second. We basically got monthly changes, so we can not worry about that. Always check the data sources. It might seem that, oh, somebody's already done this, let's just use this. But actually, when you research the quality of that data or the quantity or whatever, maybe it's better that you go to the source and get it yourself. Extract the minimum. Persistence. Do we really need to persist data outside of Airflow or whatever, Dagster or whatever it is, workflow steps, because it adds issues. Long-term storage. So again, running full-on live databases when actually you're just creating a static data source is not a good idea. And retain the minimum. Okay, Python at last code. So the new pipeline code. So this section is going to go through the base class for the scrapers. use of Golang, sorry about that, but the embedded Postgres thing for Python is a bit antique, and so it was easier just to wrap it up in the Go one, which is up to date. Creation of a Click CLI package, so we can run and test and unit test everything outside of pipelines, so that we've got easy maintainability, use of that, use of Soda, which is used to test the quality of the data that you've extracted in your pipeline. So here's the scraper, standard abstract base class Python thing. So it needs to change the units depending on whether it's Azure or AWS. It needs to scrape, which is a bit customized. And the main thing that's standard is the bulk insert of the rows. It uses pipeline mode with Psychopgy because you can then run them all in parallel, and it's not going to wait on the atomicity of the database before it will accept the data. I could have used copy, which is faster normally, but actually Psychopgy's copy isn't that fast. So and it wasn't the limiting factor. The limiting factor was the scrape speed, so it was fine to use this. There's the wrapper for embedded Postgres. You don't really want to look at Go anyway, so I'll move on. The CLI, I mean, it just wraps it and allows you to pass in a file name and where you're going to run out the port. So then it creates a CLI package using Click, old standard for Python. And this allows you to do everything outside the pipeline, as I said. So you can do the PG embed, which will run up an embedded Postgres. You can then load the schema file, create dumps if you want to, scrape the different CSPs. So that allows kind of running locally in Python to check things, test things in that way. And then there's also sort of fixtures of the data from the CSPs where it can run unit tests. I go into more detail of this in this blog post because there wasn't really time to fit it in here. So here we're looking at the Airflow step for the DAG. So it's an example step, scraping Azure. And as you can see, we just have to import the Azure scrape and PG embed from our Click. We don't want a load of functional code in our pipeline. It needs to act as an orchestrator. So then we set up Postgres, a few seconds. Then we scrape Azure, maybe 10 minutes, 8 minutes. Then if there's not a dump error, we can tear down Postgres again and notify SAC. Oh, sorry, if there is an error, we tear down Postgres and notify SAC. If there's not an error, we carry on here and validate the data. So Soda scan operators, I don't know if people are aware of it. If you've used Airflow, you probably are. So it's just a way of validating that the data that you're getting in your pipeline is good. And so we do that and then tear down at the end. So the example of the Soda test, we're here just, you want to kind of test ranges, you don't want to test details, but it does end up being a load of SQL. But anyway, it checks ranges of different pricing data, and it also checks the tiered rates at the bottom. We expect, say, 3,000 different tiered rates for the little bit of pricing we're getting. Okay, that's the kind of end of the code, I'm afraid. Sorry to say, we're down to the last bit, which is the cost, the horrible costing, how that works. So it's kind of standard what vendor pricing strategy is, and I think my own company does it, and probably most companies do it one way or another. So yeah, you'll have a free trial, which will be time or resource limited, and that will push you into, oh, there's a problem, we can't use the free trial, we've got to go to the next step. So the next step is I've called here T-shirt sizing. I don't know how many people are aware of T-shirt sizing as terminology for agile development. So it's a way where you say, you know, it's this simple thing. It will be a small size or it'll be an extra large. It's that complexity of project where it's kind of done with pricing as well. So rather than having customers have to deal with, say, oh, well, you've got about 3,000 different prices involved in that product. So we're going to show you them. No, you don't do that. You just say, you know, that's a small, that's a large, you pay this, the rate or that rate. And then you have private offers. So after you go past the large size, you have to negotiate. It's all about the haggling. So we use GitHub, and there are lots of gotchas around this. And so I'll just go into two examples to explain the weirdness of the haggling. So for GitHub, because we're quite an open source company, we've got 200 open source GitHub repositories, and they're all completely free. But we also have 1,000 private GitHub repos, and we have to pay $500,000 a year for those, and that will be the GitHub and all the workflow stuff associated with that. So if you've got workflows for your CI/CD, everything's checked, tested, whatever, as PRs go in or you use for release pipelines. They're all in Git workflow. That will use a lot of runners. And so another gotcha there is that if you're getting any type of wrapped cloud software as a service rather than just the raw resources from the cloud, you're probably going to be paying a markup. So I think I worked it out is kind of roughly 3 times the raw SKU cost of using the Azure resources you get charged if you're using them via GitHub as runners and the like. Similarly for Astronomer, which is the Airflow SaaS. And as a final example, I've got AWS's relational data service recently. Postgres 12 was out of support contract for them. So overnight, if you happen to have a Postgres 12, it would add 0.2 of a dollar for vCPU hour. You're seeing some of the units and the kind of numbers here. But actually, an average sized one only costs 0.1. So that means you would end up paying 3 times as much for your average sized Postgres if it was left on 12 after a certain date. So these sort of things can happen in cloud, and that can be scary or a problem. The other issue with cloud is the issue of infrastructure as code, which is a standard thing. We use Docker, we use Kubernetes, we use all that stuff because instead of having to work out how to set up an environment the same, we can just run that YAML and get more and more of those environments. But if we just keep spinning stuff up, it does involve quite a lot of cost. And I've illustrated this here. Islands where a lot of the cloud providers for Europe are based, 1/4 of the whole of Ireland's electricity usage is on cloud now. And if about 1/4 of that is probably just used for test dev and your kind of cloud that you left on when you were testing something, forgot about and didn't turn off. So it's kind of quite a lot of waste and cost involved in this whole game. So what's the cost of a difference between our 2 pipelines? Well, I'll kind of skip this a little bit. It's basically the new one doesn't run up a database. It's only $150 a month, but I suppose we've got 3 different environments, dev, staging, test. So you're talking about $400 a month. It took longer to load, but in effect, this whole thing is a bit illustrative of the issues you've got to take on board. Our particular case of scraping these prices is not a really heavy data usage case. It's not billions of rows. So in order to deal with this, you need a cost control strategy. So a standard thing, I don't know if you've worked for a startup or an American startup, they might talk about the rule of 40, which is you have to make 40% more than you're paying out on the cost of what you're creating as a cloud service. And so one of the big ways of making sure you stay 40% in profit is to cut the cost of what you're actually paying out, because you'll mainly be paying out to the big cloud service providers. So in order to do that, there are various kind of tactics you can use, and one of them, price transparency, I think is always really important. It's very unusual you get it. I mean, most places you'll just be spinning up environments and nobody will check how much it costs. You won't get a personalized bill saying you've cost the company £10,000 this month or whatever. So everyone should be a bit aware of the costs that they're incurring when they're using cloud. And then there's the SRE's job of having automated short lifespan things. So you might have a standard deploy for a developer and it should be destroyed after 24 hours automatically or whatever period. There's also, the main thing is regular infrastructure removal based on usage cost telemetry. So you have Prometheus and all the usage costs of everything you're running, and so SREs can then go and check and see stuff that's not really being used but is still bringing a cost, so that should be chopped out. There's different types of services. We were paying $2,000 a day for Microsoft Sentinel on non-prod infrastructure, which was complete waste, so that only run it on production. Quarterly checks of actual third-party services. So we were using Launch Darkly, but there's now open source FlagD that could be used instead. And we can just do a little bit of development and replace that, because Launch Darkly had come back to us and said, we're going to charge you twice as much. What do you think? So that's the talk. That's the different parts of it, the 4 parts. Hopefully something within it has been useful for you. Here's a little picture of the pipeline running in astronomy. As you can see, it's very simple. It just runs those up and dumps. So come to the end now. I'd like to thank Karthik and Guang, 2 engineers at EDB, for their input. Guang for the horrible maths formula, and Karthik for being our data scientist guy. That links to the blog post I was talking about. I suppose, there's, it also fires off these Slack messages. I'll show you. There you go. It's still working. It's telling me it's still working. So I'll leave you with this thought about cloud pricing. So a long time ago, I went to Morocco on holiday, and I had an ice cream from a vendor on the beach for like 50 cents. I went to a nice posh cafe with a mister, and I paid $5 for exactly the same ice cream. So when you buy stuff from the cloud, remember, haggling is good, like Moroccans believe. Haggling is good, and you will be, if you can haggle when you get to private offers, you'll get a better deal. The only problem is, instead of like 20 ice cream flavors, you've got 5 million prices, but you know, it's still worth the haggle. Okay, thanks.
Thank you.